Hi, and welcome back to the lab. Today on the bench we have a small treat for you. Today I'm going to show... What the heck is this? Yeah, not this stuff. Who the hell cares about that? Today we've got mail, and specifically anticipated mail, much anticipated mail, from, well, who the heck cares? It's Osh Park. And what we got today, or what we have today, is a few circuit boards, actually 6, it's quite a bit. A circuit board that was designed, well here, I'm just going to go bust that out while I'm here. A circuit board that was designed by a individual who frequents an IRC channel that I hang out in, and who wants to remain anonymous, so we'll call him Anonymous Bastard, or some Anonymous Bastard. And this SAB kindly enough said, well, you know, I don't really particularly want to do any kind of video on this, but you know, hey, if you want to, I'll shoot you a few boards, throw the bomb at you, and you can figure out how to put it together and play around with it. I said, sure, why not? So what he did is he put together a boost converter board. Now, you may think this has something to do with the big hubbub that's been in the news lately about a certain questionable boost converter for individual AA or AAA cells. In reality, this is completely has nothing to do with it, other than to show that these things are actually quite obvious in how they operate, and there's no magic involved. And in fact, actually, it's a pretty well understood topic in the large strokes. It's the details that are more tricky. For example, layout and whatnot. And so this is the layout that our SAB came up with. Should I call him by his first name? Maybe his middle name, Anonymous? I'll just call him by his middle name, Anonymous. So Anonymous sent this to us, and essentially it is a boost converter for the LTC 3539, which is a adjustable boost converter up to 2 amp output. Kind of neat, really darn small. So I don't know if you can see that little pointy thing here. So I'm going to go put this, I'm actually going to go and just get rid of this for the moment and reframe in wondrous, awesome YouTubing style. And we need just ever so slightly a bit of tilt on this. Please ignore the leads, they're just there for tilting the board. So what we have here is called the Butterizer. Zero connection or any affiliation with any other B-worded boost converters that are available. So this is a standard sort of topology. The tricky part here being the fact that our boost converter here, which is again the LTC 3539, is such a small darn chip that, you know, normally you try and scooch the inductor. And again, this is sort of a really typical boost converter layout. I definitely will go over the schematic, or what there is of the schematic, in a second. But essentially, in the layout here, trying to basically put the inductor, which is this guy here, big L1, as close as you can to the to the output pin here. So. Sorry, output or input? Sorry, the input. Pardon me. Anyway, so essentially, this is a fairly tight layout. It's very small, so let me just get a measurement device here. So it measures roughly 21 millimeters by there's some angling going on here, but it's about 13 millimeters. Yeah, 12 to 15 millimeters, something like that. So it's not too bad. It's a fairly small layout. Not tooting anybody's horn, but here's another one. Here's another boost converter that I put together, or I laid out. Let's try and see if we can get a hello. Focus. Oh, not good enough. All right, so this is a boost converter that I laid out. It's using a slightly different chip. I don't remember it off the top of my head, but it's not quite the same one. And again, this is all hand soldered. You can see by the fact that the most awesome crooked job on this DFN right here. But anyway, and now in this guy here, the inductor's right here, and here's the diode. This is a boost converter, but this goes from 5 volts or 4 volts to 12 volts. And again, this is the low, quote unquote, low side, and the high sides here. And yeah, I use some fairly small components here. These are all 0402s. The rest of them, these guys here, 0406, a couple of caps, decoupling, and I forget, it's also probably another decoupling cap. Oh, no, it's a compensation cap, I think. Yeah, I think it's a compensation cap in here. And our diode here, and the outputs right here. So, you know, there's all sorts of stuff here, standard topology. So let's take a look at the two layouts. As you can see, they're fairly similar. They're slightly different though, because obviously the topologies they're not exactly the same. They're both boost converters. Actually, speaking of it, no, that's right. Yeah, anyway, yeah, both boost converters. I'm not entirely sure that they're the same topology actually, but anyway, you can see the layout here is much more tight than on the one that Anonymous provided. I also didn't I also played around a little bit with the layout. So the back, it's on a solid ground plane, but I pulled the ground plane away from here, whereas on this, the Butterizer, there's both a ground plane on the top and the bottom. I don't know if I can see that easily. Yeah, it's hard to see, but yeah, there's a ground plane on both. So, but I mean, aside from that, it's the same basic thing on both, right? You've got input output, input output. This one, there's actually a control pin too, so you're able to adjust the output on the control pin based on a PWM signal. So kind of neat. But this is just a straight converter. The boost converter here for the Butterizer is actually designed for, I think it was like a 1. Down to like 0.8 volt or something like that. I have to look at the spec on the LT3539, but LTC3539, but it's probably down in the 0.8, 0.85 volt range to boost it to 1.5 something volts. So neat little circuit. We're gonna build this, and we're gonna take try it out. There'll be a few little challenges with it. So if you look at the one that I put together, you'll notice underneath the DFN component. Oh, hey, look at that. It's in 2014. Yeah, geez. Rev A, my gosh. Anyway, you'll notice here there's two vias, and I only have 2 vias underneath mine, with the copper pulled back, and that's so that I could actually heat it from below and then reflow it. So there's actually a neat little technique where you put some solder, on here, and you'll solder the chip down on it, and then what you do is you come in from behind and basically solder. You basically solder down the ground pad through the bottom, but you basically have the chip down there. You push the board down onto some flat surface like this, and you heat here, and that will actually basically squash. My fat finger's in the way here. That will actually squash the board down and the chip up flat against the PCB. Let that cool, and then you can go in and then solder like normal all of the individual pads. This is only a DFN 6, and I also, if you'll note, I also pulled the copper pads away, or the footprint a bit away from the actual device to make it solderable by hand. Unfortunately, with the Butterizer, that was not done, so this may be very difficult to solder by hand. It's probably doable. Depends where this chip actually lies and whether this footprint is a dead on or not. But the actual heat pad might be very difficult. So on the back, we don't have, unfortunately, access to the copper because it's the solder mask wasn't pulled away. So what I'm going to try and do is I'm going to try the same technique. I'm going to I'm going to put some solder on the pad here. Try and get that in as much as I can, and I am going to put a little solder here. Sorry, put a little solder on the chip. Not much, just a very thin amount. I'm going to put it upside down. Probably use some tape or something like that just to keep it in place. But anyway, turn it upside down. I'll have pre-scratched away the solder mask here so I can get access to the copper. I'll heat from the back, and then hopefully that'll be heat sunk right through the 5 vias that are stitched right here, and allow me to get that copper heatsink pad, solder, and then I'll come in and actually solder the edges here. If that doesn't work, I actually bought 2 chips, so if that doesn't work, I mangle that IC. The next step, or the next thing, will be hot air, which I don't have here, so I'll have to go to do that at work. But that should be definitely doable. Even without a stencil, this shouldn't be too bad. You can put just a strip here and then clean up a little bit. So not too worried about that. I'll figure that out. Forgot something. You may be asking yourself, why the heck is this guy doing a video on that thing for no good reason? Well, to be honest with you, the Butterizer, not the Butterizer, the Butterizer is actually a very well engineered device, in the sense that it's quite complicated to stuff this circuitry. Because I mean, you got to look at this and kind of go, well, those components are not tiny, and they managed to stuff all that into a very, very small footprint. So that's actually very interesting, and I definitely give them excellent applause, lots of applause for doing that. That's a that's a difficult engineering feat, and I'm not saying I could even come close to doing that. There's no way, or Anonymous for that matter. But definitely there's some sort of voodoo magic behind what this can, or what this type of circuit can and cannot do. And so this is sort of, we're going to just go through and build this up, which is, again, it's a bog standard switcher boost converter. It may or may not be, again, this may or may not have anything to do with the layout. In fact, why don't we just say it up right? It's probably not the topology they're using. It's definitely not the layout they're using, because they're using a much more compact layout. It's most likely not the IC they're using. And there may also be other tricks that they're using to make it more efficient, which I'm not even interested in dealing with that particular question. The question is, how does this thing actually work? What are some of the pitfalls? Because I'm sure the layout here is not amazing, just because I don't think anybody can get a switcher layout right the first time. At work we use a switcher, not unlike something like this. It's got to deliver a couple of amps, even just for a few hundred microseconds, and that can be very tough. It's very tough on our switcher for the device we have at work. So it's very difficult to do. So we're going to go do a test on this, and we'll see if we can do some pulse tests. I would love to see what the behavior in the pulse test, because again, if we're talking about any kind of boost converter, any kind of circuit that's got a motor or anything like that, batteries have no trouble providing that. It's the boost circuit here that would have to react to it, and then there's a higher drain and all that sort of stuff. So the idea of this is to sort of to put together one of these circuits, instrument and test it, measure, and try and do as good a job as we can, and show what the capabilities of this type of circuit is, what the capabilities of this specific circuit is, and see where the downfalls and where the good and the bad points, if you will, a little bit. So let's get to it. All right, so we're going to go ahead and pick away at the solder mask right around here, which is the right below the switch mode or boost converter, and we're going to try and see if we can't uncover the pads here that some anonymous dude covered up. And to do that, we're going to use an assortment of scraping tools. These are normally used on teeth, but they should equally work well on solder mask. Maybe not. That's all right. So we'll do. Hopefully this stays in the frame, but anyway, we'll see. Hopefully my big fat head's not also in the way. So what we'll do is we'll cut out. We'll score a little spot right around here. This is the spot that we want to remove the solder mask from. We want to be careful not to cut too deep, because we don't want to cut the actual copper. Now we've got to figure out how to scrape this away without necessarily getting rid of everything else. Yeah, that doesn't work very well. This works better. My thumb is right in the way here. It's really hard working with two cameras now. I have to think about two different angles. I gotta say something about this purple
solder mask is it doesn't come off easy. There we go. Now clearly this is the right design to do. You definitely want to have the solder mask over this area, at least on a production board. On a prototyping board like this, perhaps not so much. I'm going to just pull this off. There we go. This probably gives me a little bit more leverage. And what I'm really hoping is I don't kill any of the vias. That's what I'm really sort of worried about. But heck, I got a few boards, so we'll try this first and see what happens. I figure this is infinitely better than waiting until next Monday to try it out with the hot air. Which of course is the way to do this properly if you're so inclined. Okay, that's not so bad. It's turning out relatively okay. Yeah, so it's come off pretty good. I don't think the plated through. Well, there's a couple of plated throws that are uncovered. Not too many of them. Well, not all 5 of them. Unfortunately. But that's alright. In fact, just pulling back the solder mask to get the copper will already make a huge difference. So go ahead and modify the angle here. Modify the angle here. There we go. Better here? Yeah, this is actually better. Better angle to work at. Alright, that's probably good enough. I think with this we can probably go ahead and try and solder that now. It's a bit of a pain, but this, so the trick with doing this is to first of all see how small the chip is. Actually, let's go ahead and do that really quickly while we're here. Probably should have looked at that before, but oh, that's not too bad. Actually, that's rather huge. Okay, I'll take this out of the bag here. If you can see here, the actual pad right here, it's hard to frame, pad right here is, so this pad here is the IC that we pulled. Oops, we're pulling the solder mask on the backside for to try and get at from below. And as you can see, oops, it's going to probably solder on this way. I don't know exactly. I haven't seen. Look at the. I haven't seen the I haven't seen the footprint for this yet, so I'm assuming that's the way it's going to go. But anyway, so that looks pretty darn close. In fact, I would hesitate to say that that is probably way closer than it should be. So that's it's almost guaranteed to have to be hot air solvent, I think. That's unfortunate. Yeah, I'm thinking actually I may have to put this on hold until Monday so I can get at my hot air, well, the hot air workstation we have at work. That's a little bit too close, I think. That's unfortunate. It's too bad. Yeah, so that's too bad too. Yeah, I'm gonna definitely have to get at this with a hot air station instead, I think, and some solder paste, because I don't think this is at all going to work. I don't think I need a stencil, although it'll really depend on the tools you have at work. I think I can actually just put a little dab on each of those pads, so it might be a little bit longer than it would normally be, but I think we can definitely get at here and get those soldered in nicely. So yeah, I guess that's kind of it. That's kind of it until the week, until I can get back to work on Monday. So sorry about that.